All right, so on this one, they've made sure that the two radicals are the same thing. So this is really similar to saying 6x minus x is 5x. But instead of x's, instead of adding or subtracting x's, we're saying, hey, I've got 6 square roots of 2, and I'm going to subtract away 1 square root of 2, so I'm going to be left with 5 square roots of 2. And of course, you can plug that in and that, make sure that they give you the same decimal answer. Let's do one more of them. So on this one, I've got 8 square roots of 10 plus another 8 square roots of 10. That gives me 16 square roots of 10. Well, that's it. Not very exciting. All right, so what happens if the radicals don't match? They're not the same thing. So we do something that we've seen before. We try to break them down. So look for a perfect square. So I know that 9 is a perfect square that divides into the first one. And square root of 7, that doesn't break down. But in that last one, 4 is a perfect square that divides into 28. So I can do 5 times the square root of 9 is 3. And then at the end, minus the square root of 4 is 2. Like that. And now they do all match up. Hallelujah. So I've got 15 square roots of 7 plus another 8 of them makes 23, but take away 2 of them. That leaves me with 21 square roots of 7, and I can plug that in on the main screen of my calculator and that, see if I get the same answer, and I do. That's how it goes. So you are looking for those perfect square factors so that you can pull them out of the square roots so that you end up with the same radicals so that you can combine the radicals. That's the idea. Now on this, once again, we have to have the same stuff inside the radical, but the variables on the outside of the radicals also have to match. So, well, we just kind of do what we were doing a moment ago and just, break it down. So I'll just go straight down. So the first radical, I know it has a perfect square of 16 that goes into 32 twice. And let's see, I got that. And then the second radical has a perfect square of 4 that divides into 8. And they always set these up so that you're going to be able to, so you'll have like terms and you can combine the radicals. Okay, so the square root of 16 is 4. Square root of y squared is y. And inside that first radical, I'm left with the 2 and the v, and that's it. Now on the second radical, my stylus is dying. I get square root of 4 is 2, and that 3 times 2 is going to turn into 6. I just haven't done it yet. And then let's see, v to the 5th, the square root of that. Well, let's see, I could do square root of v to the 4th, which would be v squared, and then I'll have 1v left over. And then this 2 that didn't come out, he's still there. And now notice that they are now like terms because they both of these two big terms contain v squared y square root of 2v. All of that has to match. Okay, now the numbers, they don't have to match on the outside. Okay, that just tells you how many of everything that you have. Those don't have to match, but if they do, that's fine, like they did on our last one of those other problems. So I've got 4 of these things, and then another 6 of them makes 10 of them. So I'll say my answer is 10 v squared y, or yv squared, doesn't matter, square root of 2v. That's the way we do it now. I like it. Now we do the same thing one more time, except this time it's not a square root. It's fourth root, but other than that, nothing very exciting. So if let's see, so we got 4 times the fourth root, and it turns out if you factor 162, that's 2 times 81, which is 3 to the 4th. How does he do it? And then there's that x to the 5th. And then the second radical is 4th root of 512, which is 2 to the 9th. I know only math nerds know that on the tip of their brain, thus proving I'm a math nerd. Okay, so let's change the color because that's fun. No, not that. This one's better. Okay, so we're looking for groups of 4. Hey, there's a group of 4 3s. Cool. So I can pull that 3 out. And I've got 4 x's there, plus 1 extra. So I've got one group of x's. And I'm left with the 2 and that extra x. And then on the second radical, I've got 2 sets of 2's, okay, because there's 9 of them, and 8 of them would make a couple, 2 sets of 4 each. And then I've got 1 set of x's, and I still have a 2 and an x left over. And holy cow, would you look at this? I've got x, 4th root of 2x for both of them. Therefore, I'm able to combine like terms. So I've got 12 of those big things plus another 4 of them, makes 16 of those guys. And I get that. And you'll notice each time I was careful to make sure that the index of the radicals always looked like the index. Okay, so it didn't look like it was something down here where I might confuse it for something else other than the index of the radical. So that's something to be aware of to make sure you do okay on. But yeah, that would be my final answer. That's as far as it will get simplified.